Hello and welcome back to Southasia Materials Science. We've talked about testing the soil and the chemistry of concrete, but today we're tackling a massive question. How do we know if a foundation deep underground is strong if we can't see it? In construction, a pile is a long concrete cylinder driven or cast deep into the earth to support a building's weight. But once it's in the ground, we can't just dig it up to check for cracks. That's where the pile integrity test, PIT, comes in. Think of it as an ultrasound for our foundations. 1. Why do we need PIT? When we pour concrete into a deep hole in the ground, a bored pile, things can go wrong. Soil contamination. Soil can fall into the wet concrete, creating a soft spot. Neck-in. The hole can slightly collapse, making the pile thinner in one area. Cold joints. If the concrete pouring is interrupted, a weak seam can form. If any of these things happen, the pile might fail under the weight of the building. We need to find these hidden flaws before we start building up. 2. How does PLT work? The physics. The pile integrity test is a non-destructive method that uses sonic echo technology. The tools: a small handheld hammer and a sensitive sensor, accelerometer, connected to a computer. The process: we attach the sensor to the top of the concrete pile and give it a sharp tap with the hammer. The wave: this creates a sound wave, a stress wave, that travels all the way to the bottom of the pile and bounces back up, just like an echo in a canyon. 3. Reading the echo. This is where the engineering magic happens. The computer records the reflection of that wave. A clean echo. If the wave travels to the bottom and back smoothly, we know the pile is solid and continuous. A premature reflection. If the wave bounces back too early, it means it hit something, a crack, a void, or a change in the pile's diameter. The math. We calculate the pile's length using the formula. L equals 2 times V times T, where L is the length, V is the speed of sound in concrete, usually around 4,000 meters per second, and T is the time it took for the wave to return. Why PIT is essential for sustainability and safety. Peace of mind. We don't have to guess if our foundation is safe. We have the data to prove it. Speed. PIT is incredibly fast. An engineer can test dozens of piles in a single day. Cost effective. It is far cheaper to fix a faulty pile now than to deal with a leaning building 10 years from now. In the world of Southasia Materials Science, we believe that what you don't see is just as important as what you do see. The pile integrity test is the invisible guardian of our skyscrapers and bridges. Thank you for joining us today. If you found this look into the ultrasound of construction fascinating, be sure to like, share, and subscribe.